Hello, Cass. This is Professor Calvin Deutschbein, and I'm here with our November 25th lecture for CS 151. Today is one of two sort of enrichment lectures. In the last couple weeks of class, historically we have time for a little bit of an extra of something that goes a little bit more in depth. And every year the faculty sort of get to choose what they want to show off. I was recently using something I really liked when I was working through the adventure assignment, and we haven't taught it in class yet, and that is the lambda expression. So today I'm going to do a brief sort of lecture on the use of the lambda expression, how I would use it in Python, and I will do some digressions on a little bit of the history of the lambda expression. So first of all, let's start off with what is a lambda? Oops, I cannot type lambda expression. So lambda is like def. And how is lambda like def? So we can give an example of sort of the most basic function I can always think of, which is add two numbers. And so let's take the def keyword, we'll write something, add two numbers. We'll probably accept an x, which is an integer, and a y, which is an integer. We'll return an integer. And this will be return x plus y. We can trivially test this code. We can say x equals 2, y equals 3, and then we can print x, y, and add two numbers x, y. And we see we get 2, 3, and 5. Nothing too exciting here so far. There's one thing that's, to me, quite important about this that is, I think, non-obvious. When we're working with functions that are defined with def, they must have some name. And that is not necessarily true of integers like this. So here I've named something x and something y. I don't have to do that. I can change these to 2 and 3 in both positions. And we wouldn't typically do that. We would typically use variables if we're going to use the same value in two places. But I don't have to give the number some name. The lambda expression is a way to write a function that doesn't have some name. And so for add two numbers def, I'm going to create an alternative that I'm going to call add two numbers lambda. This is going to be a function. It's going to be a function just like def, but it's going to be used with the single equals assignment operator rather than the def keyword. I'm going to write it out and show what it looks like. So I'm going to take the name of my function, which is add two numbers lambda. How do I want to spell lambda? We'll do lamb. Rather than do the open and close quotations and things like type hints here, we're going to instead do single equals assignment the same way we did x equals 2, y equals 3, and then use those in later lines. Oops. X, y, x, y. I can use single equals assignment to, of course, put anything here, like 78. Let's see, add two numbers def, that is what I meant. I can assign it to something like 78. But I can also put a lambda expression here. And so lambda uses the built-in lambda keyword, like so. It is similar in some ways to def, but it differs in that after the lambda keyword, rather than providing the name of some function, there is no name. We can store it in something with a name, but by default there's no name. There is only arguments, and those arguments are, for example, x and y. We specify these arguments much the same way we specify them in defs. We can include type hints in the same way, but only in the case of, I believe, single argument lambda functions. So this gets a little bit goofy. Let's begin by just doing the minimal lambda function, which is not add two numbers, but it is the identity function. So let's take identity, which equals to lambda of x corresponds to x. This is logically the same as, let's see, we'll call it identity lam. Identity def of x, we return x. These two expressions are the same. Let me demonstrate them for you. Print, we will let x equal some string. We can print x, identity def of x, and now I'm going to show you how to use the lambda expression. This thing, which is defined as being equal to a lambda, can be applied the same way the function identity def can be applied. So we're going to use it the exact same way when we type it out. We're going to type identity lam of x. And we see some string, some string, some string. We can make this a little more sophisticated. We can specify that these should be strings. Right. You cannot use type hints and lambdas. I'm sorry. I'm in love with my type hints, but I had just started using them this term. So we have to get rid of our type hints, which is probably a benefit to some of you. Okay, we have identity and identity lam, and these are corresponding ways of expressing a function. So let's build up to add two numbers. We'll remove our type hints for standardization. And in fact, these type hints are unnecessarily restrictive because we could add two numbers with non-integer values, such as 3.5. So we have add two numbers lam. We take an x value and a y value, comma separated the same way. We are going to use a colon, the same way we use it with def, but without the enclosing parens, right? And then rather than writing a return statement, we write the value that is returned without a return statement. So we simply write x plus y, like so. Now we will print x, y, x plus y, add two numbers def, x, y, add two numbers lam, x, y, and we will see we get the same value in all cases. This probably doesn't seem particularly useful to us, and in fact it's not particularly useful. I have a tendency as a programmer now to predominantly use lambda instead of def because I don't like to split my thoughts onto multiple lines. This is more confusing to me to see the name of something and then separately see what it corresponds to. Not very many people prefer to do things that way, but importantly, that's not the usefulness of lambda. The usefulness of lambda is a way to take these functions and have what we call anonymous functions. So that's a function without a name. And we don't always need to give names for functions. So we'll take this code and we can apply it directly to x and y. And I believe I have to enclose this in parentheses. And so this is a way to perform a function without giving the function a name. When might this be useful? Well, sometimes we want to put functions inside of data structures or create a list of functions or something of this nature. I'm going to use an example of where if I may want to type something in to Python and have some corresponding action take place in response. This is motivated by the adventure project, but a little bit distinct. So what I'm going to do now is I'm going to take this notion of add two numbers lambda, and I'm instead going to begin to create a dictionary of functions. And so let's create the first one. So we will have a function dictionary. It will be equal to having a add, and that add value will be equal to this function. And then we will do one additional test where we will take the function dictionary add and apply that function. So function dictionary add, it looks up the thing called add in the function. The thing called add in the function is a lambda expression. A lambda expression is a function, so we can apply that function to two values, like so. And let's get rid of a bunch of these other ones here. We'll just see how that works. So there we have it, 3.5, 7, 10.5. This is a way to get things done if you have a lot of different operations going on. What's an example of another operation? Well, we can create another entry in this dictionary, such as subtract. Change the plus to a minus, and we perform much the same task. And we can do subtraction. We can do multiplication. And then we will do probably just regular division, which we'll call, I guess, div. We can keep going. This print statement is getting unwieldy. Let's put them all on their own line. Oops, there we go. So we have our function dictionary, add, sub, mult, divid, and then divide. And then we can do the, I did multiply twice. We could also do mod. Why not? No one can stop us. Oops. I think I said mod, right? Percent sign, yes, okay. There we go. And there's a series of different ways to go about doing this operation. I'm going to take a drink of water. I sort of want to show one other thing, which is that, at least in the case of adventure, when we're using commands, not all the commands accept the same number of arguments. So I want to give some examples of sort of a way to work around that. To do that, I'm going to first reformat this into a comprehension so that we can just directly test sort of all of our commands at the same time. What you see here is I have large amounts of repeated code. Let's see if I can remember how to use VS Code. I have function dictionary, and then over here I have boxy bracket, regular brace, x, comma, space, y, and parenthesis, comma, right? So there's sort of a lot of repeated work going on in here, and to me that means it intuitively makes sense to start thinking about, hey, can I do this with a comprehension? You can, of course, do it with a for loop, but for the sake of an enrichment lecture, I'm just going to do it directly with a comprehension. These things are the things that are in the function dictionary, so we can say for fname, function name, in function dictionary, we're going to take two values. We'll say x equals 2 and y equals 3.7. We are going to apply function dictionary fname to x and y for fname in function dictionary, and we're going to print that value. And we see that this is a way we can use all of the functions in our function dictionary. This could be confusing to us, and justifiably so we can just print out what the names are to see an example. And we get add sub mul div mod. We can also just print out what the functions are. So we can just say func dictionary fname. And you see these are all Lambda functions. And they're Lambda functions that are very close to each other in system memory. And then we can also apply that to x and y. When I was working on Adventure, I created something very similarly to this, but it did not necessarily work in the exact same way, in that not everything on Adventure, for example, take accepts an argument and north does not. So how do I deal with that? Well, an example of an arithmetic operation that is able to accept only one argument is the negation operation. Let's see an example of that. I don't know what else to call this other than negation, but if I have 7, I can negate it by applying the negative sign in front of it. I can say x equals 7, and then I can return negative x, and I get a negative 7 back. It is perfectly reasonable to create a negation. And how do I do that? Well, negation only accepts one argument. And by convention in Python, when we don't care about some argument, we can put an underscore there. Now, usually we wouldn't provide extra or insufficient number of arguments to a function. But if we're doing this with a dictionary, where every possible function might need different numbers of arguments, we can also separately structure our functions such that each of them receives the maximum number of arguments, and then only use however many arguments we need. On Adventure Game, I would expect this to have everything accepts one argument and just doesn't use it. This is how I would accept one argument, or accept 2 arguments and only use one. And so how does this work? Well, we'll have a slight difference here. We'll simply return negative x. And what does that give me? Negative x. We could also see an example where we get 0. We're not allowed to use the double underscore twice. Or that's a single underscore. What else can we put there? Oh, we'll just call them all x and y. It doesn't hurt anything. You'll note in my version of VS Code, when I don't use a variable, it leaves it in this slight gray color. I don't know how visible that is. And there we have it, a way to get access to 0 directly. Getting 0 is not exactly a classical arithmetic operation, but we can imagine that it's something that's possible to do. So this is one way that I might use Lambda expressions. Of course, the alternative to this is you write a bunch of these, and then you can include this instead. And functionally, it will behave identically, but you won't get to see all of your code next to each other and edit it directly, which may or may not be of some benefit to you. I don't know what I clicked. I do. Okay. Let's just run this again and take a look. Okay. So here's an example of using Lambda functions inside a dictionary to be able to do a lot of different operations without writing a large number of functions. I certainly, personally, I would have solved image shop this way. The image shop operations in many cases are much more complicated, but things like flip vertically and flip horizontally could have been managed in this manner. Let's take a look at some other things we can do. So most commonly, I see Lambda functions in something like this, a function dictionary. And these function dictionaries, I have learned to call them dispatch tables, because I think the understanding is some entity, in this case, this testing script, dispatches some functions. In the case, these, how do I think I hold Alt and Shift, dispatches these functions on some values whenever it is called. So I think it's like a dispatcher for like emergency services or something like that is my understanding. I've taken to calling these dispatch tables. I looked it up a little bit. I didn't see a lot of other people calling them dispatch tables. I will probably be calling them dispatch tables. So to me, a dispatch table in Python specifically is a dictionary of Lambda functions that are not named, so they are anonymous Lambda functions. So perhaps we can say a dictionary of Lambda functions is a dispatch table, or we can say a dictionary of anonymous functions. Anonymous because they have no name. Okay, so one of the things that people tend to write in programming languages, of all things, is other programming languages. And what we have here with these arithmetic expressions is sort of the beginning of a very basic programming language, and sort of the, I don't know, perhaps one of the earliest programming languages, we could argue, was Alonzo. I'll write that out. Alonzo Church. Alonzo Church was the faculty member that taught Alan Turing, Alan Turing being the genius that cracked the Enigma machine. Alonzo Church developed this way of describing programming, before there were computers, right, on mechanical devices, known as the lambda calculus. And lambda calculus was based on this idea of lambda operations. They were functions without names, and the two things a function could do is a function could be defined and a function could be called. So we have function definition, which looks like this, and then we have function application, which looks like this. Or we can perhaps say f equals lambda of x, and then we can simply say f. These notations are all equivalent. When we're working with a programming language, a natural thing to do is to write expressions like add 2, 3 in a programming language and see to what values they evaluate. And so I'm going to do that now, and I'm going to begin to do that using Python input. So let's begin with an example of Python input. So I don't have any code running here. I've defined a few things. I think I don't need any of that. This is my dispatch table. So let's begin with a simple thing. I'm going to accept some input, and I'm going to do nothing with it for now. So let's just take that. We'll run this code. This program is waiting for me to input something. And so if I input something like hello, and then press enter, the program completes. There's no remaining lines of code, and it responds. I can put a print statement before and after that, awaiting input, and then we can print input received. I'm going to write RCD because I don't remember how to spell received. Awaiting input, hello, input received. What you have probably seen on the adventure game and on other tasks is that input accepts an argument, and that argument is the prompt text. So this works much the same way. We can say hello, it's on one line now, and then we can say input received. It is a simple enough matter to do something like this, and then this, of course, is how Python was invented. For the sake of this operation, instead of putting the slashes there, I'm going to put a lambda there. So I'm going to grab that from a web browser real quick because I don't remember how to do lambda. Ooh, that doesn't work. Ah, the terminal lambda. Okay, excellent. Oop, I've broken everything. So I can get a lambda prompt, right? And I can say hello. And for now, I just get input received. One way to see what the input is we can store the return value of this input function. And I'm going to call this user text because I am the person that is using the input, and I'm providing some text. And I'm going to say what that user input was. So I can say, hello. User input is not defined. It's called user text, my mistake. Hello. I kind of don't like this being split horizontally and vertically, actually. Do I know how to change that? That's better. Okay. Hello. Okay. This is becoming relatively similar, I think, to Adventure Game. It is heavily inspired by the Haskell programming language and by the Lambda calculus, which are sort of other historical programs that have run on computers. Let's make it a little more interesting by actually providing some way for a user to perform arithmetic operations, right? Sort of the most basic things that are done in a programming language, the first things we did in the Python programming language when we were learning it together. So the way I'm going to do this is I'm going to take the user text, and I'm going to begin to process that text. The first thing I'm going to do is I'm going to write a note to myself about what kind of text I expect to receive to make it easier to process that. And so I'm going to say, I'm not going to say anything. Well, okay. This isn't quite arithmetic, but you may request arithmetic operations with 3-letter, all capital names, and provide up to 2 values. Looks good to me. I noticed that I should probably be doing line breaks here. So I'm going to break on request. And I'm going to break on, well, we'll run that again. Everything broke. This isn't quite arithmetic. Close. All capital. We'll do it anyway. There we go. Good deal. So let's begin reading user text. User text, at least in the convention of Adventure, is a command, a space, something else, and then so on. So I'm going to use the sort of technique from the splits lecture to split up that text, and then I'm going to provide that text to my function dictionary. So let's go through that process. First of all, we have user text. We're documenting what user text is. So is that how you do it? Debug and print. User text. I do not like VS Code. Okay, user text. Hello, user text. Excellent. I should probably put a quote there, and I should specify this as debug. Very good. Very good. That makes sense to me. Okay, so after accepting that user text, I think I want to break that up into splits. So I will say that the splits equals user text dot split, and then we might as well print that as well. I don't think I need a space there. So we can say hello world, for example. That will give us some splits, and then we can say just hello, and we will have a list of things that are provided through input. Okay, so what am I imagining we do next? Well, once we begin sort of splitting up and decomposing things, I do think it makes sense to begin imagining how we turn these things into sort of the arithmetic expressions we have. And I would expect these arithmetic expressions to occur over a 3-letter command, then a number, and then some other number. I think I will probably compel myself to use integers, but that's probably neither here nor there. One thing I want to do before I get too far down that rabbit hole, though, is point out that it's relatively annoying that I have to rerun the program every time I test it. So I'm going to put this inside a loop, and it's going to be a while true loop. It's going to loop forever. And then I can have a good time. When I put this inside of a loop, I should probably now include an exit command. I'm not far enough along to process that, but let's go ahead and have an exit, and then we will invoke exit or perhaps quit. All right. Let's take those splits and begin to actually process them. So I'm imagining the first thing is a 3-letter phrase, and then there could be some arguments or not. One way to ensure that there are always going to be some arguments there are I'm simply just going to add 2 nuns to the end of this. No one can stop me. I am powerful enough to do this. And when I do that, my list is always minimally of length 3, which means I can always take the first thing in the list, look it up in the dictionary. Excuse me, I have to cough. And then I can go on and apply the sort of values. Probably in the case of this dictionary, I shouldn't be providing none, because I don't believe I can add none to none. I bet I can, huh? It's probably going to be 0. Nope, okay. So instead of that, I'm going to provide whatever the default integer value is, which is 0, so I'm going to do that by typing int here. Hello, hello, 0, 0. There we have it. With these splits, let's take the command x and y will equal splits, and then we're going to print command x and then y. Hello. Hello is the command, x is 0, y is 0. But we can also say hello world there. Okay. Get too many values to unpack, which is not actually a huge problem because we can just cut this off at 3. Hello there world. We get to the 3 values. I can put as many words as I want, and I just take the first 3 or a few, and I still get an extra 1 at the end. So I certainly always have a list of at least length 3, and sometimes I have a list of more, but I don't care about that. What I'm going to do now is I'm going to begin processing commands. In Adventure, we had a tendency to command is equal to upper, probably? I don't know how Python works, hold on. Python s equals high. Do I say s dot upper? That works, okay. Command, all right, well, what happens if there's other things in the string? We'll just do that up here. So what I want to do is, oh, I'm not done yet. Okay, these things are all capital, so I'm going to make all of the input capital. How am I going to do that? Let's see if I do plus 2, 3. That is, and then we do lowercase plus 2, 3. That's beginning to work pretty well. Okay, that works well enough for me. So, what do we need to do now? my impression is that what we want to do now is we want to take the first command, we want to look it up in our dictionary, and then we want to take the second and third, we want to take the 0th element of the list, and then we want to take the 1th and the 2th element and provide those as arguments to the function that is named by the 0th argument. So we take this, which is not currently in our dictionary. I said plus instead of add, which is how we're going to deal with synonyms in a minute. And then we take this value and we take this value. Something important to put in mind is that at this point in time, if I say plus 2, 3, that 2 and that 3, those are both strings, so I cannot integer add them together. So I'm going to have to turn those into integers somehow. And that's an easy enough thing to do. We can either use multiple assignment, we could also use a list comprehension here. We'll say, what, x plus y? Plus 2, 3. Very good. And now we're able to add things together successfully. But we don't want to just always add things together, because if I say right now, for example, minus 2, 3, I said mins, but that doesn't matter. That doesn't work great. So, okay, what are we going to do? Going to take a drink of water. We have to start taking commands and looking it up in our dictionary. The way I would do this is I think we probably need to have a default case if we don't match anything. So first thing I'm going to do is I'm going to check to see if the command is in the dictionary, and I'm only going to check the first 3 letters. So how do I get the first 3 letters of command? Let's do that next. Well, we really want command to equal command 3. And then let's just print out, I guess we can just say that still splits, right? I guess I don't know how I want to think about this. Interesting. Well, makes enough sense to me. Let's print them. Command x, y equals, what is it? Command x and y. Oh, I have to exit over here. Command x, y. Those lines are still a little bit too long. Letter all capital names and provide up to 2 values. And I'll just print it anyway. That looks a little better to me. Okay. Plus 2, 3. That all seems fine. Very good. Add 2, 3. We're getting there. Okay. I can now get add coming in here, right? I think that all makes sense to me so far. So let's go ahead and take this and try and actually look up commands and deal with them. So first thing we're going to do, I think, is we're going to say, I can do an if, but I don't want to do that anymore. Let's just do print. This thing called function dictionary, that should be called dispatch table. And okay, I don't like typing, so I'm going to call it functions. We're going to print f's of x, y. That's all we're going to do. Now we're going do that over here. Okay, so we're going to do add 2, 3. Dict object is not callable. I needed to look up the command in the dictionary. Add 2, 3. Very good. Sub 3, 2. Very good. Exit. There we go. Let's set debug to false. Add 2, 3. Sub 3, 2. What should I do? Neg 3. Neg 3, 4, 5, 6. We only do the first one. And there you have it. I think that's, I guess I think that's kind of cool. I don't know if you think that's cool, but I think it's cool. Let's see, I need to do error handling. So let's say I'm a silly goose. I'm a known silly goose, and I try to do plus. So pl is not in the dictionary. I get an error. I crash out. I don't want to do that. So how am I going to handle this? Command in fs and add 2, 3 plus 2, 3. Simply nothing happens. We just throw out the command directly if we can't process it. I think there's one other thing that I can probably put something in here that doesn't work. I don't necessarily want to package things up as integers that aren't integers. So we can do some error handling there as well. I think the most natural thing to do is to check to see if x and y can turn into integers, and then only convert them if they can. So I think there is a built-in Python thing, for example, that looks like isDigit, perhaps. Lucky me, right? So I can go through here and I can check the isDigit of the index 1 and index 2 elements, which I would call perhaps the 1th and 2th element, but they look like the 2nd and 3rd element to us sometimes. It is this number and this number, and it may be the things that come from here. So let's see how we would want to perhaps deal with that. And let's clean up this code a little bit. I think we hopefully don't need debugging anymore. We'll find out. This is getting quite clunky, and we probably don't necessarily want it anymore. These are, in fact, supposed to be integers, though. So how do we deal with this, I think? What we want is, we don't really care what the first thing in command is, because no matter what, we're taking 3 of its letters, making them all uppercase, and then looking it up in here if it exists. So command, I think we can put literally anything in for the first 3 letters. I can say, that's Python. Put in just random text, I can put in numbers, I don't know, I'm not going to get an error no matter what from there. So the only way to get an error is to put something in that's not an integer in the integer position. And I think I can add 7.5 and 3. Okay, I cannot do that. I cannot turn it into an int. So that's good to know. Let's try and deal with the case where these things might not be integers, right? So what we're going to do is we're going to say x dot isDigit is how we check to see if x is a number. I'm going to introduce something new. It's called the ternary operator, and it is an inline if statement. So what I'm going to do is I'm going to say x equals int x if x is digit. I get a little squiggle here, and then otherwise it is going to be 0. What is this doing? Well, Let's get in Python. That's actually the easiest way to check this. So let's say x is 8. No, we should start with x as a string. Let's say it's the string 8, right? What is the type of x? It's a string. So what do we say? Well, we say x equals int x if x dot is digit, else 0. And what's x? Say we started with x as 8, the other kind of 8. I think that's not allowed, so we replace it with 0. So this is a way to take something that might be a string that represents an integer and give me back 0 otherwise. And also now it makes much more sense to place nuns here. So let's go ahead and do that. We need to do this for y as well. And I don't really like repeating that code. So how can we deal with that? We can say xy equals int n. We'll call it string for s in xy. That line of code is just a little bit longer than I want it to be. I don't think there's a really great way to get it shorter. So it's just going to have to be that way, unfortunately. I'm sure there's a way to make that better. What's that? Okay, let's go ahead and get out of Python. We'll run our code. We can add 2 and 3. We can add 3.5 and 4. By golly, it worked. That's pretty cool. That's not what those two things are. Oh, it turned one of them into 0. That's funny. So we can add hello and 4, right? And just everything is treated as 0. It's not a number. I don't know if that's the best way to handle errors. That's kind of up to you. You could certainly print something there, right? I don't know that you necessarily want to do that, but it is allowed. Let's see. What else should we do? I wanted to... Oh, we should test 0. Oh, did that not work? Non-type object has no attribute as digit. Okay, they should be empty strings. That's fun. That didn't occur to me. This is why you test your code. Okay, let's see. Add 2, 3. 0. Very good. Neg 0. Neg 1. And so on. And I don't have to capitalize these correctly. Okay. Very good. I'm quite pleased with that. One of the things I mentioned that I think I should do is add some synonyms processing to this. And so I'm going to work quickly through doing some synonyms processing. And from there, I think we will probably call it good for the day. So let's make some synonyms. Synonyms are also going to be a dictionary, I would assume. I think the most obvious one is the one that I typed in by accident. Oops. Is that the end of that line? Which is plus for add. I think we're quite likely to get minus for sub. We might get times for multiply. We could get, geez, I don't know anything other than divide or mod. We might get percent for mod. I guess one way you might want to process this is that minus and negation are like, maybe those are the same thing and you actually want to count how many integers you get. That sounds a little too hard. And then we might get quit for exit. So we'll take exit there. Let's go ahead and process these synonyms and get them working. So this line 31 here, is where we're dealing with commands. We're taking the command and we're finding the 3-letter phrase. I think all we have to do there is check to see if command 3 is in the dictionary, and if it is, we will update it, and if it's not, we won't. So that is sins command 3. If, I gotta close my brackets, if command 3 is, nope, not is, in sins, else command 3. And I spelled sins wrong. So this is again the ternary operation. I have a single line if statement. I can say +2, 3. I can say -3, 1. I can say subtract 3, 2, and so on. I can say -3, 2 with a regular capitalization. And then if I put 3.5 in here, of course, I get the unexpected behavior. I don't know how I would deal with things that aren't integers, so I would have to think about from a design perspective what I actually want to do there. That's not so much knowing how to write the code as it is knowing how to think about what code I want to write. Oh, we should check quit, and it works. And I think that's really cool. What is one reason to have introduced, smoosh this, the ternary statement here? Well, it just could be the case that you need to write an if statement inside of a lambda expression. And what's the most obvious one of those? Well, I think the sort of conditional arithmetic operation I use the most is absolute value. Absolute value is built into Python. It takes the distance of some value from 0. It's a built-in function. We could call it directly. That feels a little bit like cheating to me, so I'm going to write my own absolute value using lambdas. Absolute value is very similar to negation, so I'm going to start there, and I'm going to copy it over. Absolute value is going to take some value, and keep in mind we're ignoring the second value because absolute value only takes one argument. It takes some value, and it returns that value if that value is greater than 0, and otherwise it negates that value. Negating a negative value causes the value to become positive, and that's how absolute value works. So I've added an additional feature to sort of my not quite programming language, right? I have to remember the keybinds to run this. And now I can probably take the absolute value of -7. Oh, I think I can't put negatives in? Wait, oh, I didn't think about that, because I think Python s equals -7 s dot is digit. Oh no, I can't use is digit to check to see if things can be negative values, but I bet I can still take int of s. Ah, I'm so sad. I thought that would work. I wonder if there's like an is number. Is numeric, perhaps? Yeah. Is that what it is? Is numeric, and then let's see if s is 7 is numeric. So what is numeric checking? I think it probably checks a string. Okay. so uncommonly deal with negative values. I am bamboozled. And I really would like to be able to put negatives in here, which makes me a little sad. So how am I going to write something out that's conditional? Well, why don't I just check to see if something is even or odd? So I'll check something that is odd. And let's see, it is true, and since it is true, we're only returning numbers, so we should return the truthy value 1. So we're going to return 1 if x percent 2, else 0. Odd 7, it is. Odd 6, it is not. Good enough. I don't know how to type in a negative value in order to get the absolute value demonstration being interesting. This isn't quite the same thing as writing your own programming language, but it's awfully close, and I separately find it awfully enjoyable. So I hope you had fun using sort of these dispatch tables, perhaps using these synonyms, maybe writing a few lines of code and dealing with a few corner cases here. Again, this is all inspired by a specific mathematician who was a tutor for Turing, who went on to crack the Enigma machine, and is one of our sort of most valuable computer scientists for helping save the world. And I had fun learning about this. I was really grateful when I started learning Python and found it had Lambda expressions. It's kind of this toy thing that you don't need until you need it, and when you need it, it makes your code, in my view, substantially easier to work with, especially once you can get used to things like ignoring values in some cases and always ensuring that you have some minimum number of values, and so on. I would not necessarily say that this is good code, but I would certainly say it is interesting code, and I hope you like it for that reason. What I'm going to do now is I'm going to take this code and I'm going to put it on GitHub somewhere so that you can take a look at it at your leisure. I'm going to put that GitHub code in the everywhere that this recording is, and from there you'll be able to play around with it if you like. Thank you so much, and I hope you have a happy and safe fall break.